All right, good afternoon, everybody. I'm Remy Baumgarten. I work at ANRC Services, and today I'm going to present a tool I've been working on for a little while now, and I hope you enjoy it. Some of the contact information is up here, if you want to take that down. Otherwise, I'll give you the link to the slides and the link to the tool at the end of the presentation. So a little bit about me. Again, I work for ANRC Services. I mostly do mobile malware talks. Here's a few of the cons I've done on my talks at. Presently, I am doing R&D at ANRC, mostly with iOS, Android. I also do security instruction for the company as well. Before that, I was a senior consultant on the malware team at Booz Allen Hamilton, and before that, I was an intern at Secure DNA. So why a new tool? There's a lot of new tools out there that are coming out all the time, especially at DEFCON, and I believe that there was a gap that I wanted to fill, especially in the area for Mac and malware analysis. I also believe that visualization is a great way to learn how complicated things work, and that's one of the reasons why we created this tool, MacoViz. There's also not many security products out there to analyze Mako files. There are a few. I'm going to show you them. I'm going to show you the pros and cons, and I'm going to show you what I'm trying to fill the gap in with. There's also a lack of web-based free reverse engineering tools to use on any device. Most of the tools require that you use Windows or Linux or Mac. In this case, you could use it on the iPad or Android, which is pretty unique. There's also really a strong need, at least from what I've heard about the ability to quickly identify malicious files and automatically create snort signatures on the fly, especially to people without much training. So some of the tools that I've used that I really enjoy that were a big inspiration to this project were IDA Pro, OTool, ClassDump, MacoView, PTool, OTool, NG, and Hopper. A few of these, especially MacoView, have been really helpful in just basically making sure that everything I was doing was correct. So with this chart, some of it's arguable. I did the best that I could to my ability. However, there's 5 categories right here, and with MacoViz, I tried to do basically a yes check mark in all of them. And that's making it graphical, having multiple architectures, making it network security aware, easy to understand, and be very easy to use. So basically the goal of the project, again, is to combine the features of all those programs and speed up the process, plus add this network security element to the mix. Ultimately, at the end of the day, the goal is to help the network defender understand the Mako file format better and provide an effective and efficient way to analyze a particular binary for malicious behavior. So with that, I'm introducing MacoViz in beta. It basically presents the Mako binary in a visual format. For those that you don't know what a Mako file is, it's basically the file format used on iOS and Mac devices. If you're familiar with Windows, you're going to see PE file format, and with Linux, it's going to be the ELF file format. So, and basically, in turn, this makes it easier for anybody to see visually how the file is constructed. And it might not be that new of a concept to you if you've used IDA Pro. There's a little ribbon band at the top that shows you the whole entire file structure broken up. So we took that a step further with this tool, though, and you'll see in a minute how that works. So you're going to see the visual representation from the header through the load commands and into the corresponding sections and segments. It's also interactive, so you can zoom into the segments for more detail. In addition to that, we also wanted to create a back-end graph and visualization plus an analytics system for graphing the binaries disassembly, very similar to what you're going to see in IDA or Hopper if you're familiar with that. Currently, we're only supporting these architectures right now, 86, 64, ARM6 and 7. Again, that's only for Mako, but we have the ability and we'd like to expand it if there is enough interest to other architectures. We also wanted to keep this program not only visual but also accessible, again, so that means we could use the web browser and any other type of platform. Again, more design features. We wanted to keep the back end as Mac as possible. And by that I mean that when Apple updates its specs for the Mako file format, which it has done very recently, the tool is automatically already updated because the system's keeping up to date with everything Apple's doing. So the whole entire tool is working in its native environment, and by that it's always updated and relevant by default. We also get to gain access to the LLVM disassembler for the most accurate assembly we could feed into our analytics engine. We also make use of many of the open source utilities that Apple provides and many other web open source utilities for this project as well. So this is the main page of what the application looks like when you go to the website. At the very top you're going to see a few different things that you could take a look at. The first is going to be the instructions, the white paper, which I really highly recommend you read if you want to really see how to use the application. There's about 3 malware samples that are walked through step by step. And it will show you exactly all the features and how to use it. I only have 20 minutes today, so I can't show you everything. There's also FAQ and contact information. So essentially all you need to do is upload your binary and then click the upload file. But before you do that, there was something I want to mention to you when you actually do this. If you're not familiar with how Mako files work or how Apple packages their applications, this is an actual diagram of an IPA. So an IPA is an iPhone application or iPad application, and essentially it's a zip file. So if you change the .ipa to a zip and then you extract it and then you open up the payload folder and then you right click, you could show package contents, and then inside that you're going to see a whole entire directory containing database files or resources and then the actual binary itself. If you run file on one of these binaries, especially for in this case on the iPhone, you're going to see 2 architectures. In this case for Facebook, you're going to see ARM version 7 and ARM version 6, both Mako ARM executables. So at the very top of the application, it's actually divided into 2 different parts. This is the Visual File Explorer, and at the very top you can see that there's a key that will show you what all the colors mean along the way. So at the very top you're going to see the header, the load commands, executable code, data, file architecture, Objective-C, static info, and code signature. And by clicking in any of these major segments, you basically could drill down to get further information about what is going on inside that file format. So in this example, I clicked on the file header itself, and you can see the magic number right there is feed face. And then the CPU type, which is 12, and then the CPU subtype, which is 9. And that basically just stands for ARM version 7. In the future, we're going to add documentation pop-ups. So if you could hover over anything, it will basically give you the information, more information about what exactly you're looking at in the Visual File Explorer. This is just the load commands. Again, another view of what it looks like when you're drilling down into different parts of the file format itself. The second part of the application is the graph visualizer, and this contains 3 major areas. The first being the interactive graph function search, the second being the security assessment, and the third being the graph data display pane. I'm going to show you what all 3 of those look like, and then I'm going to give you a demo of the application itself. So the first is the interactive graph function search, and at the very top left, I know it's kind of hard to see, but it says functions, and it's basically going to do an analysis of the whole entire binary and give you a drop down menu of all the functions in the application itself. So when you select any of those functions, it's going to automatically draw that graph for you right below in the graph pane. Okay. The second one and the third one, the name xrefs and the strings, basically are going to list all the strings and the cross references for you. And when you select one of them, it's going to search the binary and then populate the results into the search results, which is the last drop down menu on the right. So whenever you select the names xrefs or the strings, remember that search results is going to contain all the functions that are going to have any of those references that you looked at when you did those searches. The second part is the security assessment. Right now, the way that we're doing this is we're identified code segments which are using APIs and functions flagged as security risks. We're also identifying an automatically generated network and static file signatures for the binary. Basically, we're doing this in two ways. The first way is the network way by detecting network domains, IP addresses, URLs, web protocols embedded in the binary itself. And the second is calculating a unique binary signature for the file itself using the Mako magic value in the file's header plus unique 16 bytes from the binary string table. Using those, we're going to basically get snort signatures, which I'll show you in a second. By selecting a potential security risk, the functions are located containing the risk. So this is the security assessment, what it looks like, the pane itself. And if you see the drop down right here, you can see that I've selected the system function call. So by actually selecting that, it's going to fill in the search results, which you saw just a minute ago, and it's going to show you all the functions in the application that are using that call in the application. So you can drill down directly to the places where those potential security risks will be, so your analysts could look exactly at what potential malicious behaviors might be inside that binary. So when I do that system, it's actually doing a search right here. You guys.
Okay, you know the drill. This is how it goes, right? What are we doing? Shot the noob. All right. We're going to do it as fast as we can because we know it's a short talk. All right, we need one person from the audience who's new. First hand right here, yellow shirt. Let's go. Up on stage. Paul's not having a good time.
Someone had a late night.
Congratulations to all of you for getting up. How's the speaker doing so far? Doing okay?
Some soft kitty
Paul needs 2, right? Paul needs 3.
All right, to our new speaker. Paul. We have 2 more to do this hour.
Nobody has any expectations.
All right, thanks a lot.
All of a sudden.
You said he feels better all of a sudden. So yeah, so by clicking that security scan results system, we're actually, you could see this little pop up here. That's basically looking through the whole entire binary and finding the.
Is he doing a good job?
Thank you. So we find 3 functions containing the reference to system, and then we update the search results containing that. So if you look at the search results, you're going to see 3 functions where you could click on it. And right here you can see the actual search results. Those are the functions containing the places you want to look at. All right, so the bottom, the last part, which contains most of the stuff you're going to be looking at, is the graph data display pane. And this is divided into 6 tabs. The first being the graph view, which is like your IDA-like interface. It's completely interactive. You could zoom, scale, highlight, and a few other things. You're also going to have your hex view, just like IDA, strings, Objective-C. We're doing that via class dump, disassembly via LLVM disassembly, and then also network security, which is going to contain your snort signatures. So the graph view right here, with a few highlights I've demonstrated, you can see it looks, again, very similar to IDA or Hopper. How are we doing this? Basically, we're parsing the OTool disassembly of the binary, and then we're doing a lot of magic. I don't have too much time to talk about it, but we're turning it into GraphViz charts, and then we're taking those GraphViz charts into HTML and placing them as SVG with JavaScript and CSS to give you all the visual effects. So with the hex view, basically you click on the visual file explorer like this. So in this case, we're clicking on dynamic loader info, and the dynamic loader info, it's basically, if you're going to look at that, it's just all the information you're going to see for that particular type of information from the visual file pane is going to be hex values. So this is what the hex values for the area looks like. This is the second pane. The third pane is the strings, and the strings are displayed in full and provided with short names on the left for easier lookup references within the code. if you look at the disassembly by itself with the tools Apple provides, it doesn't give you short names. So we had to develop an algorithm to actually do this and then have it cross-reference to a particular area within the file format itself where these strings actually existed. So this is a little bit tougher than it looks. For the Objective-C part, we're using class dump here, and class dump basically generates headers from the Mach-O files. If you're not familiar with it, it's basically a reverse engineer's wet dream if you're working with Mach-O file format. It's awesome, and I'll show you an example of how effective that is when we're looking at one of the samples here in a minute. The third is the next panel is a disassembly view, and this is taken from LLVM disassembly. Again, we're paginating here, so you could basically change how many lines you want and then just change pages. And the last tab, which is the most useful to the network analyst, is the network security pane. And here you can see we developed some snort signatures, and you can see some URLs, and you could basically plug and play these right into your IDS system. These are going to contain domains, IP addresses, URLs, and protocols if you in fact find that the file itself is malicious. The bottom is a file signature, and again we're doing that unique 16 bytes from the string table that I talked about earlier. So with that, let me give you a demo of two examples of analyzing different samples. The first is the Yan2 Trojan, and the second is Mac Defender. A little bit of background about both. The Yan2 Trojan, it basically infects Chrome, Firefox, and Safari in the Mac. It uses social engineering to install an HD plugin. So let me pull up this video. Okay, so again, this is the front page, and I'm going to select the Yan2 Trojan, which is called Custom Installer, and I'm going to upload it. And at this point, it's going to analyze and generate the graphs. It's going to analyze all the assembly of the file. It's going to basically break apart all the functions, create the SVG files, and then it's going to do some optimization to minimize the network load over. So when you pull it down, it's going to be a lot smaller. We also calculate the entry point right here. So this is what it looks like, the Yan2 Trojan. And you can see I'm opening up the header right here, and you can see a few different values. There's the magic number, the CPU type, and so forth. Again, I clicked on the top level, and now I'm looking at the load commands, and you can see all the different load commands here. And then I'm going to go down to the bottom and quickly look at the security assessment. And you can see that there's 16 security risks that we deemed that are essential to look at. And with that, there's a few things I want to show you. This is the graph view. You can see I can move it around. This is a strings view. And you can see a bunch of potentially interesting URLs and file locations that are kind of sketchy that might immediately pop out to you. And then Objective-C, so with the Objective-C, this is again class dump. So I took a look ahead before, and I found a really interesting method or interface for a method in here, and it's called extension installer. So this one immediately was pointed out, and one of the methods right here is called install Safari extension. So basically what you can see right here is there's an address. So what I'm going to do is I'm going to copy that address, and I'm going to plug it right into the functions right here. Just paste it right in there, and then it's going to automatically generate the graph for me, and then display this particular method. So you can take a look at exactly what's going on in this installation method itself. So this is the graph view, and I'm going to show you the whole entire size of the graph view by clicking Zoom Extent. This is the whole entire method displayed right here. So I'm going to zoom in. And I'm going to show you a few different things of what exactly is happening within this installation itself. The first thing you can see right here is str library Safari extension. And that is a short name for the string, which you can see at the bottom right here. So this is the URL. You probably can't see it, but it's library Safari extensions. And that's going to be the location or the directory of where they're going to want to install this. And that's a highlight right there. And then the next thing you're going to see is the Safari extension plist short name. And I'm going to go ahead and find that string over here. and see what exactly that means. And you can see that it actually is the extensions.plist. So what I could kind of infer right now is that they're actually modifying the extension plist for Safari. Looking further down in this routine, I'm basically looking for something else. Probably they're going to write a value. So taking a look further into this, I'm going to zoom in and see that essentially there's going to be a string called str enabled, and they're going to be writing a 1 to it. So we're going to see an LEAQ, or a load effective address. And from there you could basically see that the value is turned on to 1. So that's enabled right there. There's a lot easier ways to do this. I wanted to show you the hard way. And let's see how much time I have left. 3 minutes, great. And for the strings, basically I could have just gone to str Safari extension right here, and it's basically going to show me the same exact graph that I pulled up before. So it's basically the reverse of what I was just doing. So looking down, it's going to show the same graph that I just had. So let me, due to short of time, let me skip forward a little bit. This is a disassembly view, and this is the snort pane right here. So again, we have all our snort signatures of this Yantu Trojan that we could plug directly into our IDS system. All right, so moving forward, the next one is Mac Defender, and we're going to build this chart right here. And right here, I just want to point out that Mac Defender is actually multiple architectures. That's why you saw 2 big blocks. One of them was x86 and the other one was x64. For this is really interesting because what we're going to do right here is we're going to find a method called is file infected, because what Mac Defender is the fake antivirus. So we're going to look for this interesting method called is file infected. And by pulling this method up right here, we could see the whole entire routine that is going to be used for the actual virus detection for this application of this malware. So this is the entire antivirus routine. Fast forward a little bit. So looking closely right here, you can see that basically this is the world's smallest AV file infection detection routine in the world. It uses a random number generator for scan time, and that's pretty much it for the the way that this file actually scans this file. So just taking a look at one routine due to shortness of time. It's very interesting. The last thing I want to show you today is the network security. So this is basically what you get at the end. Snort SIGs. These are mostly porn URLs. So what this application is doing is going onto the net and hitting a bunch of porn URLs. So you can put this all into your Snort database right here. With that, let me give you the links for this presentation. So at the top, this is the beta URL. We don't have too much bandwidth capacity, so if you do hit it, you might have trouble if everybody starts hitting it once. Just try it a little later. And below is a slides URL too. The white paper is also listed on this Macroviz beta URL. And if you have any questions, I'll be over there outside, and I hope you enjoyed my talk. Thank you, everybody.